In this section, we are going to talk about different types of alkanes that differ slightly from the list of alkanes that you should probably have in front of you, and how to name these different types of alkanes. So right now I'm just calling them weirder or stranger alkanes. And specifically in this section, we are going to talk about alkane molecules with something that is called a substituent. So alkanes with substituents. I will explain what substituent means in a moment. It's nothing terribly fancy, but over here on the left I have a cartoon version of heptane. It's heptane because it has 7 carbons implied in the skeletal structure. Here's carbon 1, number 2, number 3, 4, 5, 6, 7, which makes it heptane. In this case, I wanted to draw out the hydrogens explicitly. I wanted to not make them invisible because they are going to help us understand what a substituent is. So if you look at these carbons in this chain, they have hydrogen atoms attached to them. Now, for the most part in a skeletal structure, they will be invisible, they won't be drawn out. But in this case, we're going to talk about this particular carbon sitting on this corner, and this particular carbon happens to have 2 hydrogen atoms attached to it. So I'm going to draw those out. There they are. Under some circumstances, you can make molecules that look an awful lot like heptane. They have 7 carbons, but they might be missing a hydrogen. There might be something in place of the hydrogen. And so I'm going to show that here. So this molecule over to the right has 7 carbons as well. 1, 2, 3, 4, 5, 6, 7. But in the case of this carbon over here on this corner, it doesn't have 2 hydrogens in the way that heptane has 2 hydrogens. It has 1 hydrogen, but some other atom has come along and taken the place of the second hydrogen that used to be attached to this carbon. In this case, I'm saying let's pretend that the atom that came along and took the place of the hydrogen is bromine. So what you can say is that bromine is substituting for this hydrogen over here. And this is a completely different molecule now. It's not heptane. It's different because it has bromine stuck on this carbon. So what you say is that this is a bromine substitution, or you can say that it is a bromine substituent. And technically, you are not supposed to say bromine, even though the atom that is attached is a bromine atom. What you do is you drop the INE in bromine, and you add the letter O. So what this actually is a bromo substituent. That's how formally it's supposed to be pronounced. Or if you want, you can say that this is a bromo substitution. So this molecule over here is an awful lot like heptane because it has 7 carbons, but one of the hydrogens is missing, and in its place is a bromine atom. So this is called a bromo substituent. Now, usually, as I mentioned with the skeletal structures, you won't write out the hydrogens that are attached to carbons. But you do write everything else that is not a carbon and a hydrogen out. So we do actually need to still write the bromine atom out and point out that it's sticking out from this carbon over here. It's attached to that carbon. But for the most part, you won't see this hydrogen atom drawn out. It'll be implied. You can think of it as invisible. So this, what I'm circling here, is just a more formal cartoon version of this molecule over here. And again, this molecule that I'm circling, it's almost like heptane, but it's not exactly heptane because one of the hydrogen atoms got ripped out, and in its place, a bromine atom was substituted. So, anything that substitutes for a hydrogen atom when attaching to a carbon is called a substituent. So that's all substituent means. Now, this type of atom, this bromine atom, we haven't talked about this, or at least we didn't talk about it very much early in the course. There is a strip of atoms, a strip of elements in your periodic table that starts with fluorine. So this strip comes from the upper right portion of the periodic table, the right side of the periodic table. It starts with fluorine, there's chlorine, bromine, iodine, and astatine. We don't talk about astatine that much. But this strip of atoms has a common name. All of these atoms together are called halogen atoms or halogen elements. So anytime that you have a halogen element substituting into an alkane, the name of the halogen, you drop the INE in the name and you add the letter O. So if there was a bromine atom substituting here, it would be called a substituent or a bromo substitution. If there was a fluorine atom substituting here instead of a bromine, it would be called a fluoro substitution. If there was an iodine atom substituting there, it would be called iodo, and if there was a chlorine, it would be called chloro. So this little name, bromo or fluoro or iodo, is going to ultimately be part of the unique name that describes this molecule. But I need to give you a little bit more information before we can give this molecule its unique name. But what I want you to take home from this slide is I want you to know what a substituent is. It's any atom or group of atoms that substitutes for a hydrogen when being attached to a carbon. And that this particular group of atoms, the halogens, fluorine, chlorine, etc., when they substitute in, you actually don't say that it's a technically, you're not supposed to say that it's a fluorine substitution, although it's fine by me. You're supposed to say that it's a fluoro substitution. This is a chloro substitution, etc., etc. Now, as I mentioned, this thing has its own unique name. It's not heptane. We talked about this being called a bromo substitution, so is the name of this molecule over here bromoheptane? That sounds like a reasonable name to give it, since it's almost like heptane, and heptane is over here. Why not call this thing bromoheptane? That is a reasonable guess. Unfortunately, it does not give a unique name to this particular molecule. Why doesn't it give it a unique name? The reason is because you need to specify which carbon atom the bromine is attached to. Over on this molecule on the top, it's attached to this carbon over here, this invisible carbon on this corner, which is kind of close to the left end. But this molecule also has bromine attached, but the bromine is attached to a different carbon. It's attached to a carbon on this corner, which is a little bit further away from the left end. So if you didn't know any better, you would want to call this molecule up here bromoheptane, but if you use that rule and that rule alone, you would also call this molecule down here bromoheptane. And it turns out that these two molecules are not the same thing. The bromine is attached in a different spot. This bromine is attached further away from this edge than this bromine is. So these molecules are not the same, and because of that, they need a unique name that makes it clear which one you're talking about. In addition, you could stick the bromine atom on the carbon atom that's in the very middle of the chain, and this molecule here is completely different from the top two. So all of these molecules, this one on top, this one in the middle, and this one on the bottom, you could call them bromoheptane, but that's not a unique name. That doesn't clearly tell you which of these molecules you're talking about. It looks like I lost the slide there for a second, so let's go back. So just calling them bromoheptane doesn't tell you which one you're talking about. So we need a slightly better way of describing what's going on. So how do we unambiguously name the molecules on the right? So the way that we do it is, I sort of alluded to a moment ago, and that is you need to also specify how far the substitution is from one of the edges, and that will end up allowing you to uniquely name each of these types of molecules. This one is one away from the edge, this bromine is. This bromine is 2 carbons away from the edge, and this bromine is in the middle. So how do we do this? What are the actual rules? They're shown on this slide. So the way to do it is, I'm going to show you a handful of rules, and then we'll go over the rules in more detail. So the first rule is to look at your molecule and find the longest chain of carbons. So this one we know it has 7 carbons. It's the only chain of carbons that it has. And then you basically have to give a number to each carbon. You start from one end or the other. You start from either the left end here or the right end, and you number the carbons. You call this carbon 1, carbon 2, carbon 3, all the way up to 7. Or if you started from the right side, you would call this carbon 1, 2, 3, 4, 5, 6, 7. And then you have to, however, in this case, you could number either from the left to the right, or you could have numbered from the right to the left. The proper way to number is you pick the numbering system. You number the carbon atoms starting from the end that's closest to the substitution. So in this case, the substitution is here. So this is the end that's closest to the substitution. And then the way that you give it the name is the name will consist of the number of the carbon where your substitution is attached, the name of the substitution, whether it's bromo, chloro, whatever, and then you add the name of the alkane as the suffix. Now, this may be confusing to you. I will go over this molecule in more detail on the next slide. So let's start with this molecule, and let's follow the rules. Find the longest chain of carbon atoms. We already said the longest chain is 7 carbons. So this is kind of like heptane. Then we have to number the carbon atoms from one end to the other. And we have to start numbering the atoms starting from the end that's closest to the substitution. So we could either start from this end here or from this end. But the end on the left is the one that's closest to the bromine substitution, so we're going to start numbering here. And this is going to be carbon number 1, number 2, etc., etc. And that's shown here. So here is me numbering in red from the left end and in blue from the right end. And clearly the bromine is closest to the left end, so we're going to use the red numbering system. And if we use the red numbering system, then this carbon over here on this corner, this carbon that the bromine is attached to, it's carbon number 2 according to our numbering. And because of that, then we follow these rules for naming, for giving this particular molecule its own unique name. The name of this molecule is 2-bromoheptane. And if we follow the rules, you give the name as follows. The number of the carbon where your substitution is attached. Our substitution is attached to carbon number 2. So that's why we put a 2 here. Then we give the name of the substitution. This is a bromo substitution, so the name should begin with 2-bromo. And then we add the name of the alkane, and the alkane with 7 carbons is heptane. And that name of the alkane is the end part of the name. So this entire molecule up here, unambiguously named, is called 2-bromoheptane. It's called heptane because it has a chain of 7 carbons. It's called bromo because there's a bromine substituted somewhere along onto one of the carbons in this chain. And it's called 2-bromo because the bromine is attached to carbon number 2 relative to one of the ends of the chain. And this is called the IUPAC name for this particular molecule. This particular molecule, if you wanted to describe it to somebody and not go through all the hassle of drawing out the structure, you would say, I am working with 2-bromoheptane. And this information is enough to allow some other experienced chemist to know exactly what molecule you're talking about. They'll know that you are talking about this particular molecule and not any of the other variations like this one that I showed you on the previous slide. This is not 2-bromoheptane. Only this one is. So let's figure out the name of this other one here, where the bromine is a little bit further away from the edge. Same thing, we follow these rules, find the longest chain of carbon atoms. It still has 7 carbons, so the end part of the name we already know is going to be heptane. We have to number the carbons from one end to the other, and so we can either number using the red numbers, or we can number using the blue numbers, 1, 2, 3, 4, going from right to left. And we have to pick whichever numbering system gets us to the substitution fastest, whichever end is closest to the substitution. In this case, it's the red numbering system again, so we number from left to right. This bromine is attached to carbon number 3 in this case. So the name is going to start with the number of the carbon where the substitution is attached. So the name is going to begin with the number 3. It's a bromine substitution again, and it's attached to heptane. So the name of this particular molecule that I'm circling, or this cleaner version up top, is 3-bromoheptane. And this name, 3-bromoheptane, helps us uniquely identify this molecule when comparing it to other molecules that are pretty similar. This was the one that we named on the previous slide. This is 2-bromoheptane. So the name of this molecule is different from 3-bromoheptane. And so this basically helps you, or helps the chemist to figure out what type of molecule you're talking about specifically. Here's a different example. You can pause at any point to try to work this out on your own. I will go through this in a moment. Again, here are the rules over here. And so again, I believe this chain of carbons is 7 carbons long. So it's a heptane. 1, 2, 3, 4, 5, 6, 7, yep, heptane. And then the rules are to number the carbon atoms from one end to the other. And number them starting from the end that's closest to the substitution. So if you look here, I basically put this bromine over near the right edge. So in this case, we don't number the carbon atoms from left to right. We don't start and call this carbon over here at this end, we don't call it carbon number 1. We actually have to number using the blue numbers in this case, because this end here is closest to the substitution. So this is carbon 1, this is carbon 2 in this case, and our bromine is attached to carbon number 2. So we go through these rules. You give the name by listing the number of the carbon that your substitution is attached to. It's attached to carbon number 2, so the name is going to begin with the number 2. You list the name of the substitution. This is a bromine substitution, so we're going to call it 2-bromo, and it is attached to some chain of carbons that's 7 long, so that's a heptane. So the name of this thing is going to be 2-bromoheptane. It's not going to be called 6-bromoheptane. And the problem that many beginning students have is that you are accustomed to writing numbers and reading words and numbers from left to right. So your natural tendency is to always number starting on the left side. But in this case, the rule is basically saying no, you don't do that. You number from right to left because our substitution is closer to the right edge. What you'll notice here is that this molecule, this one here, its unique name is 2-bromoheptane. But a couple of slides back, I told you that this molecule over here, the name of this thing, is also 2-bromoheptane. So why are they both named the same thing? The reason they're both named the same thing is because they actually are the same thing. Even though they don't look the same in the way that I have drawn them, that the bromine here is on the left side and the bromine here is on the right side, that's really just an illusion. The reality is that you could take this molecule and flip it from left to right, or from right to left, and you would see that all of the atoms line up in the same spot. And because this thing can be flipped so that all of the atoms line up in the same spot, they actually are the same molecule. So this molecule here is called 2-bromoheptane, and this molecule here is called 2-bromoheptane. And it's not a mistake that they have the same name, because they actually are just two different cartoon representations of the same molecule. Now, I'm sure you're thinking, well, can you make this any more complicated? Of course we can. It's possible that you can have a chain of carbons and there can be more than one substitution. So this is one type of molecule where there are actually two substitutions. There is a bromo substitution and there is a chloro substitution. But the rules are pretty much the same. You find the longest chain of carbon atoms. This particular molecule has a chain of 7 carbons. You number the carbons from one end to the other. You either number them 1, 2, 3, 4, 5, 6, 7, or you number them from right to left in the same way. Here, the rule changes slightly. You number the carbon atoms starting from the end that's closest to a substitution. So you could either number here, and this would be 1, 2, 3, or you could number from the right to left, 1, 2. And you pick the numbering system that brings you to a substitution first. And then the way that you name it is in the same way. You name each however, there's a slight difference, I'm sorry. You name each substitution in alphabetical order. And then you number each substitution based on what carbon it's attached to, and then you add the alkane chain name as a suffix. So let's do that here. We could either number using the red numbering system as I mentioned, left to right, or we could number right to left using the blue numbers. The blue numbers bring us to a substitution first. We only have to count up to 2 before we hit bromine. If we use the red numbers, we need to count up to 3. So we're going to use the blue numbering system. And then we have to list the substitutions in alphabetical order. So this is bromo, this is chloro. Looks like B comes before C, so bromine is going to be listed first, and then you list the number of each substitution as well. So I'll show you what I mean by that. The name of this particular molecule is 2-bromo-5-chloroheptane, because the bromine or the bromo substitution is on carbon number 2 using the blue numbering system, and the chlorine or the chloro substitution is on carbon number 5 using the blue numbering system. So this particular molecule, its unique unambiguous name is 2-bromo-5-chloroheptane, and the heptane is there because this chain of carbons has 7 carbons in it, and heptane has 7 carbons. So that's how you name unambiguously alkanes that have more than one substitution. And you can do this for as many substitutions as you can squeeze onto that chain of carbons. Here's a different one. I've changed the number of carbons in this case. You can pause and try to figure this out on your own. This might be a little bit tricky, but you should at least be able to get close if you follow the rules. There's a slight twist in there. But let's see, find the longest chain of carbons. This thing has 1, 2, 3, 4, 5, 6 carbons. So the alkane with 6 carbons is hexane. So the end part of whatever this molecule's name is going to end in hexane. Then we have to number either from left to right or from right to left. We have to pick whichever numbering system gets us to a substitution first. Well, they both are at the same distance. So we could either number from left to right, or we could number using the blue numbers from right to left, because in both cases we count to the number 2 and we bump into a chloro substitution. So to make things easy, let's use the red numbering system, and then you name each substitution in alphabetical order. Well, they're both named chlorine, so there's a slight twist. What you do is you list the number of the carbon that each chlorine is attached to. So this one is attached to carbon number 2. And this chlorine is attached to carbon number 5. So the beginning part of the name is going to be 2, 5. And then you put in the letters di, meaning 2. So di is sometimes a prefix for 2. And the name of this particular molecule is 2, 5 dichlorohexane. It's hexane because the chain of carbons has 6 carbons. It's chloro because there are chlorine substitutions here. And it's dichloro because there are 2 chlorine substitutions. And the 2, 5 tells you what carbons in the chain those 2 chlorines are attached to. There is 1 chlorine attached to carbon number 2. There is 1 chlorine attached to carbon number 5. And so the name, the unambiguous name of this particular molecule is 2,5-dichlorohexane. If you wanted to number using the blue numbering system, you would end up with the same name. So it doesn't matter which numbering system you choose. And just to point out that this di gets stuck in there because there are 2 chlorines. If you had 3 chlorines, it would be called trichloro. If you had 4 chlorines, it would be called tetrachloro, etc., etc. 5 chlorines substituted, it would be called pentachloro. And then you would list each number, the number of each carbon that each chlorine is attached to, using this numbering system. 2, 5, whatever, if there were more chlorines attached. And this numbering system is true not only for chlorine, but for bromine, for iodine, for all those other types of substitutions that we talked about in the previous slides. So that ends our discussion of halogen substitutions on alkanes. In the next section, we are going to talk about a different type of substitution.